Hi, I'm Elizabeth with Logicwalk. In this lesson, we're going to take a look behind the scenes and explore how the Logicwalk operating system represents a file system internally. Before we begin, all operating systems run differently. The Logicwalk OS is a cleaner, simplified version designed to support your learning. Now let's begin. In the Logicwalk OS, the file system is just a list of folders, and each folder is represented as a map with two main parts. In this context, a map is a structure that stores pairs of information. Each pair consists of a key and a value. The key is a name, such as a file or folder name, and the value is the data or location associated with that name. The first key of a folder's map is called files. The value of this entry is another map, where each key is a file name and each value is the file's contents. The second key of a folder's map is called folders. Its value is another map, where each key is the name of a child folder and each value is the index that tells the operating system where that folder is located. That value is an internal location or index that is assigned automatically by the operating system when the folder is created. Let's look at an example of a file system. At the top is the root folder, which is always located at index 0. In this example, the root contains two child folders, documents and photos, located at indices 1 and 2 respectively. There are no folders or files in the photos folder, and inside the documents folder, there's a text file called birthday that contains the date September 1, 1970, and another folder called math. When the math folder is created, the operating system automatically assigns it index 3. Inside the math folder, we find three text files, pi, e, and square root, and each of these files contains numerical data associated with its name. Suppose we ask the operating system to print the contents of the following file using the cat command. The first thing the Logicwalk OS does is split the file path using the /. This produces a sequence of names that the operating system must follow in order: documents, then math, then the pi text file. Before we begin, let's take a look at how each file and folder is represented or mapped inside the operating system. The LWOS then pops the stack, looks for the popped elements in the current folder, and moves to the child folder. This process repeats until the stack is empty. The operating system always starts at the root folder, which is located at index 0. From there, the LWOS pops the first element from the stack, which is documents, and looks for it in the root folder's map. Because the documents folder is mapped to the index value 1, the OS knows that the documents folder is located at index 1. The operating system then moves into that folder. At this point, the stack is updated and now contains this. Now the operating system pops the next element from the stack, which is math. The math folder is mapped to index value 3, so the LWOS moves into that folder. At this point, the stack is reduced to this. Next, the LWOS pops the text file from the stack and looks for it inside the math folder. Since the pi text file is the last part of the file path, the Logicwalk OS is going to look in the file's map. The text file's name pi is mapped to the value 3.14159, which is the data stored in the file. The stack is now empty, which means the search is complete. The Logicwalk OS retrieves the value and prints that value on the screen. That wraps up this lesson. In the next lesson, we'll build on this foundation by exploring how the Logicwalk operating system uses these internal mappings to create, update, and delete files and folders.